Hi, Riza.
Hi.
Okay, we'll start in a few minutes. First, we want to admit the people, and we'll have a small introduction, and then the stage is yours.
Yeah, okay. And I think I have the access to share my screen. Yeah, yes, I think. Yeah.
You all good?
Yeah, all good, all good.
Hello, everyone. Welcome to today's exciting hands-on workshop, where we'll dive into the world of microservices with the help of Conductor. And hi, I am Anjana, and I'll be the host for the evening. So, whether you're a seasoned developer or a beginner, today's workshop is going to be extremely helpful for you. And today we have with us our amazing speaker, Riza Farheen, who is a developer advocate at Orkes, known for making complex tech concepts very simple and actionable for everyone. And she has previously worked at as an information engineer at Mitsogo, where she specialized in managing content and ensuring information security. So we are going to learn about how Netflix was able to transition from to microservices using Conductor and explore the real world applications of Conductor. And you will also get a chance to explore how you can apply Conductor into your own projects and also clear all your doubts regarding to the topic, anything related to Conductor. So without further ado, I think we can hand it over the stage to Riza. So Riza, are you ready?
Yes. Okay, so thank you, Anjana. So I think I'll just share my screen and begin with the session. So, hi everyone. I'm Riza Farheen, developer advocate at Orkes. So, welcome to the session. So, as you all know, we are particularly running a specific conductor track for the hackathon. So, I will let you know about what conductor is and the basics like about the microservices, orchestration. And towards the end of this session, I will show an example of how you can build a simple workflow in Conductor using Java Spring Boot, that is printing an hello world example. And so this serves as an introductory section for the hackathon, and we will be sending like two of my colleagues to the venue. So on the hackathon day, you will be having two mentors there to help you out with the doubts and help you resolve the errors that you run into while building the applications. And after the session, I will share all the documentation blogs and the example links with the organizer, so you so you can go through it after the session. So I think we'll begin. So this is the agenda. So we'll begin with what, why, when, monoliths and microservices, and then move into the two main microservice pattern, which is the orchestration and choreography, followed by what is conductor OSS, and then we'll get started with Orkes conductor and the fundamentals of it. And we do have a playground, which is a free developer sandbox, which you can use for building or submitting your projects to the for the hackathon. So, yeah, let's begin. So, initially, let's look into the evolution of applications. So, I think this microservices and the terms orchestration may be completely new, or some of them, like some of you might have heard about it somewhere. But so, let's look into what is this evolution that came from the mainframe application to the distributed applications. So, in the early days, the mainframe applications had a monolithic architecture. So, where both the application logic as well as the data were tightly integrated and centralized on a mainframe computer. So, this was like the initial form of application. And then, with the invention of the personal computers, the logic and the data started to decentralize, so the applications could now run on individual machines, which reduces the dependency on a centralized mainframe when compared to the previous era. And then, with the client server model emerged, the application logic was distributed across the client machines, but still the data remained centralized on a server. So, with this model, the scalability and performance of the application architecture started to improve. And as the internet became widespread, applications began to move towards a more centralized model again, with both the logic as well as the data residing on central servers, which is accessible through web browsers. And then Web 2 introduced like a more sophisticated architecture with the separation of concerns. That is, the logic was decoupled into three tiers, which is a browser, app server, and the database. This model introduced a better method, which where the applications had better scalability, flexibility, and user interactivity. And finally came the distributed application, which is having like a decoupled logic and data. And you can see that the logic or the each step in the application is distributed across microservices. And maybe in a simple term, we can say that distributed applications that run on multiple computers within a network at the same time, and they can be stored on servers or cloud computing platforms. So, unlike traditional applications, which is running on a single system, the distributed applications can run on the multiple systems simultaneously, and which is one of the main advantage of this. So that is about the quick history behind the mainframe, the evolution from the mainframe to the distributed applications. Now let's look into what is the difference between the monoliths and microservices. So this image gives a quick overview on the difference. So you can see when it is a monolithic architecture, all the components will be like encapsulated within a single code stack. And when it comes to microservice based application, each of the component is like separated into each microservice, which is having its own database. So, and a central orchestrator is going to manage all these activities between the microservices. So let's look at in detail. So before that, let's look into what is monolithic architecture. So, monolithic architecture can be imagined as a huge container where all the components of an application are tightly coupled together. So, the term monolith itself is defined as a structure that is indivisible and slow to change. So, the case of applications built with this architecture is also the same. So here, the entire application code is encapsulated within a single code base, making it difficult to scale and manage. And this is like a generic approach in app development. And almost all the developers might have started their app development with this architecture. So it is like just understand that everything will be written in like a single code base. So if your application is having like 1,000 lines, so if you want to debug some issues, you'll have to go and find where the issues, which is like creating many limitations. So let's look into the limitations first. So the most prominent challenges posed by the monolithic application includes the first one is the code complexity. So as and when, as I've mentioned, you have the entire code application in a single stack. So as and when your application grows, it becomes very difficult to manage this code base. So imagine that you need to make a change to your application. So in this case, the entire stack of the application is to be accessed and updated, which increases the complexity of handling the code. And the failure of a single component may result in taking down the entire application. Second one is a slow development cycle. Since the application code is maintained in a single container, it takes like more time, which slows down the development process. Third one is the scalability. And the monolithic applications are difficult to scale because, as I've mentioned, if you need to update an individual component, you cannot do so. What you have to do is you need to like access the entire code base, update the make the changes, which further increases the complexity. So it is difficult to scale. When you want to add a new feature, it is like difficult to scale. Next one is the reliability. So it's difficult to debug the application because here the entire code needs to be debugged if an error occurs, which reduces the reliability of the system. And third one is the final one is a difficulty in adapting to the latest technology. So any changes with the technology, such as they could be language updates or framework updates, will require updating the entire code of the application, which is again takes time, and will you may run into error and you need to resolve them, which is again a limitation. So what do we do to overcome these challenges posed by a monolithic application? So that's where a microservice architecture comes into play. So in a microservice architecture, the applications are built as individual services where each component has its own database and business logic. So they communicate with each other through APIs or message brokers to complete the scope of the application. So now let's look into the two main microservice pattern, which is a choreography and orchestration. So in a choreography pattern, you can see that there is no centralized coordination between the services. So any service can consume the event, perform the corresponding action, and pass the event for the next service to consume. So in this pattern, the order of this execution is embedded inside the services themselves. So this can run into many errors. For example, we can say that you are making some payment and there is like a payment error, and let's say the payment was like declined. So in that case, for a smooth functioning of the application, the next step should be like initiate a refund or process refund. So there should be something to control this execution of these flows between various this thing that is called the orchestration. Now you see in this image, the same application is implemented via the orchestration. So in that case, all the services are linked to a centralized orchestrator, which orchestrates each services in a predefined order, thus completing the scope of the application. So for example, consider the case of a food delivery application. So the different processes such as order processing, inventory check, payment, notification, etc. are handled as different microservices. And each services can be updated, tested, scaled, and deployed independently, which makes it easier for different teams to collaborate and work together on the application. So take the case of Swiggy itself, the one of the famous food delivery application in India. So even the Swiggy is running on Conductor. So we our platform is having two variant, which is the open source version and the enterprise version. So Swiggy is running on the open source version. So whenever you can, from this image, it is very clear that each of the step in your application can be handled as different microservices. So so let's say some issue occur with your payment service. The developer need to debug only this particular service, fix the issue, and bring the application back to production, which is like, as I've mentioned, one of the main advantages. And you can see that each of these, you know, that every services or every step may not be coded in like a single language. So, for example, for some process, some tech stack would be great fit, whereas Java couldn't be a fit, Python could be a fit. So depending upon that, you can like each service can be coded in your preferred language, and each it will have its own database, so that it will so this microservice based application can overcome most of the challenges which we have discussed right now regarding the monolithic application. So these are the benefits. So it is like almost ticking off the limitations from the monolithic. So new feature or change deployment is faster. So I've mentioned, suppose in this application, this feedback service is not there. So suppose your project manager comes with a proposal that you need to integrate a feedback service to the application. So the developer needs to work only on this, debug it, test it, and finally deployed to the production, so that the applications will still be running. However, we can just plug in a new service or new feature with much ease. So that is like new feature change deployment is faster. And then it is a improved resilience. So here there is no direct communication between the different services. So the resilience is like improved. And next one is a fault isolation and easier debugging. So that's like what I've mentioned. If there is an issue with the payment service, we need to only isolate that particular service, fix the issue, and bring back the application to production. And technology agnostic. So you can like code different services in your preferred language. And there is an opportunity to experiment, and the scaling is easier. And there is like team collaboration. So different parts of the application can be worked by different development team in different languages, and they all can be clubbed together to finally form the application. So these are the benefits. Now let's look into what Conductor OSS is. So as I've mentioned, Conductor OSS is a leading open source orchestration platform for building applications. And the Conductor OSS was formerly known as Netflix Conductor, and it was developed at Netflix and later open sourced. So the creators of these Netflix are the team behind the foundation of a company, Orkes. And Netflix discontinued the support for this Conductor OSS in December 2023. And the Orkes, along with the community members, are the official maintainers of the Conductor OSS right now. Now, what is Orkes Conductor? So Orkes Conductor is the enterprise version of the Conductor OSS, which is available on major cloud platforms like AWS, Azure, and GCP. Now let's look like these are some of the common features which is available in Orkes Conductor, which is not present in the Conductor OSS. So I think if you are familiar with the open source communities and all, so some companies will have two products of which one is free to use, that is called the open source version, which in our case is Conductor OSS, and one is a paid version with more features, and that is the Orkes Conductor. And for Hackathon, we have the playground for this paid version, which is Orkes Conductor, and you can utilize that for submitting the projects. Almost all, I think a few features may not be accessible, but still almost other features will be accessible, which you can try out for creating your projects. So this is like some of the use cases or some of the different ways by which you can integrate Conductor. So if you want to like build your complete application, you can build your application from scratch using Orkes Conductor. Or say you have an existing application or an existing project and you want to maybe add one layer, orchestration layer to the application. So in that case, you can use the APIs to start and manage the workflows. And then there are concepts like workers, which I'll go in detail in the coming section. So let's look at the different ways to get or install Orkes Conductor. So it can be set up in different ways. So if you prefer running the open source version, which is you can install and run locally using Docker. And there is the enterprise version. And for Hackathon, you can make use of the Orkes Playground. The links will be, which will, I think, which is shared with you already. So let's look into the fundamentals now, which are the task, workers, and the workflow. So let's begin with the task. So this task can be called as the basic building block in an application. So I've mentioned in the previous diagrams I've shown you have seen like different services. So you can imagine these different services as different tasks. So say you are placing an order and something a section of code is to be handled for the order processing. So consider that as a single task. So that is a concept of task. It is a basic building block in an application, and the task is further divided into three types: system task, operators, and the worker task. So the system task means suppose you want to call an HTTP endpoint. So in such cases, there will be a built-in HTTP task. All you need to is add the HTTP task and provide the required input parameters. So the workflow will run accordingly and will produce the output. So it is like a built-in task. This is just one example. There is a lot of system tasks which can be utilized for various use cases, which I'll be detailing in the upcoming slides. And then the operators are similar to the programming language constructs. So suppose if you want to evaluate based on a statement and then check the condition and then proceed with the application, you can, such as switch cases, or if you want to run something in loop, or if you want to run something in parallel, in such cases you can make use of the operators. And apart from these inbuilt system tasks and operators, there might be requirements for you to you to custom code, and in that case you can add a worker task and you can code your required thing specifically in a worker which is outside Conductor, and link this worker to the Conductor workflow. So I'll show you how you can do it towards the end of the session. So let's look into the different types of system task available. So if you want to make calls to remote services that are exposed over HTTP or HTTPS, you can make use of the HTTP task. And second one is the HTTP poll task. It is similar to the HTTP task itself, but it is used to invoke the endpoint until a specified condition matches. So you can give a specific condition here in addition to the other parameters which is available in the HTTP task. And next one is the inline task. So it helps to execute necessary logic at the workflow runtime using some evaluators such as GraalJS. So it is like a kind of inline for JavaScript. So there is like examples available which will be shared with you. And then there are event tasks. So there are external eventing systems such as AMQP, like AWS, SQS, Azure Service Bus, Kafka, etc. So suppose you want your workflow to listen to the events that is coming from this system, then you can make use of this particular event task. Then we have the business rule task. So if there is a spreadsheet or a CSV, files which is having some data, and you want to evaluate this quickly using conductor, so you can make use of the business rule task where you can define certain things and the workflow will evaluate the spreadsheet for you. Next one is a JSON JQ transform task. So it allows the processing of the JSON data supplied to the task. So if you have some data that is supplied and you want to process it into some format, you can make use of the JSON JQ transform task. And then we have the webhook task. So like HTTP, webhook is an HTTP based callback function which facilitates the communication between conductor and other third party system. So if you want to receive data, real time data from other applications to the conductor, you can make use of webhook task. And there are different kinds of webhook integration that is available. For example, let's say you have a GitHub repo and you want to get notified like when someone is submitting a PR to your repo. So in that case, you can create a webhook in Orkes Conductor, and there will be a link which will be generated, and you can use it to integrate it with your GitHub webhook, so that that integration is successful. And whenever somebody submits a PR to your repo, you can make use of this integration to get notification based on that. That is just one example use case. And there is another webhook integration that is available is a Slack webhook integration. That is something which we have internally deployed within our company. That is, we have integrated a Slack channel with the webhook, and we have created a Slack bot, which is the stand-up bot, which is asking for updates to the employees. So we have scheduled this to run every day at 9 a.m. PST, so that 9 a.m. PST, this bot would send a message to all the employees asking for their updates, and they will give a time period, the reply should be given like in 30 minutes or something, or maybe in 2 hours or something. And these replies are collected and posted to a Slack channel where the manager will be there, so that it is easier for the manager to go through it. So it is like daily reminders need not be given to the employees to post. So we are like a remote company where the employees are globally working. So this is kind of an internal use case which we implemented, making use of a product itself. So the video guide of this is available. The example which I've mentioned right now is available, which will be shared with you. You can go through it and maybe tweak it a bit and provide us a submission for your conductor track. And next one is a JDBC task, which is used to execute or store information in databases like MySQL. And then there are certain things called update secret tasks. So you will be having like sensitive data, like some API keys or some authorization keys, which should not be provided in the workflow definition, because this workflow will be accessible to all the developers in the company. So this is something confidential and should not be exposed to everyone. So in that case, you can create that as a secret in Conductor, and you can provide a name for the secret. And whenever you want to use this key, this value, you can refer to the name in the workflow, so that this value is not exposed to everyone, but still everyone can use it. So that is one example. So if you want to update this like while working with some workflow, you can make use of the update secret task. And next is the update task. So if it is like to change the status of the other task. Now, yeah, one more thing is there, which is a get sign JWT task. So if you have a JSON web token, you can sign the JWT task quickly by adding a get sign JWT task and providing the like signing details. So it will be like automated. And now let's look into the operators. This is like simple to like if you're a developers or if you deal with programming, you can quickly understand this. So if you want to create some branching logic, you can make use of the switch task. And if you want to execute a list of tasks as long as the condition is true, you can make use of the do while task. And if you want to run something in parallel, you can make use of the fork join task. And if the dynamic fork is similar to the fork join task, but it is used in situations where the number of forks is determined at the runtime. And when something is running in parallel, we want function to join all these outputs together. So that is done using join task. So an example of this fork join task, let's say that whenever you order something, you are getting notified by SMS as well as emails, right? So in such step, we can make use of a fork join task. Where will be two forks that is running in parallel, one for executing the email and one for executing the SMS. And a join task will update it finally and say that the notification has been sent. So that is how when you place an order, you are getting notified through two communication channels, that is the SMS and email. Then wait task. So if you want to, if you need a workflow to be paused for an external signal to continue, you can make use of the wait task. Next is the set variable task. So if you have some variables to be reused in the workflow, let's say you can define it using a set variable task and reuse it at the different sections. And then we have the dynamic task, which is used to execute one of the registered tasks dynamically at runtime. And then if you want to start another workflow from your current workflow, so let's say you have a subscription workflow, so not going to renew that. So in that case, you need to start another workflow to notify on the what is the next step. So that is one example of starting another workflow. And sub workflow, that is if you have like a common set of code which is to be reused at different sections of the application, you can make use of a sub workflow task. An example could be if you have a payment system in a company and it has to be used in different cases. So in that case, you can create a payment workflow and add it as a sub workflow in your required application, so that your payment system is like being replicated across all your applications. Then we have the terminate task. So if you want to terminate the current workflow with the termination status and reason, you can make use of the terminate task. And the example which I mentioned is a subscription workflow. So if let's say you are discontinuing your Netflix subscription, in that case, your workflow will end at this terminate task. And then we have the terminate workflow, which is used to terminate other running workflow. And one more thing is if you want to retrieve the workflow details, other workflow details, you can make use of the get workflow task. So that is about the operators. And next one is the alerting system. So our alerting system means if you want to execute, I think to simplify it. So let's imagine that you have an application that is completely built on Conductor and it is running, and you are having a service level agreement with your customer that the application downtime should be always, let's say, 95%. So you need to ensure that your application is running like most of the time. 95% means most of the time. So in that case, you can use the Conductor itself using this query processor task to query and check that your application is failing. So let's say we will query for the failed application instances, and maybe like every 10 minutes we can do this. And whenever the instances are found, we can take this and send to an alerting system. So Obsgenie is like one of the popular alerting tool. So you can query the data and take the data and send alerts to the Obsgenie system, so that the required, and the Obsgenie is like the configuration from the tool, and you can configure some on-call developers to look into issues, so that they can every 30 minutes your application will be checking its status, and when there are failure of the application, through this Obsgenie task, it will be alerted to the developers so that they can take a look at this application, fix it, and bring back your application to the production. So a video guide on this is also available in YouTube, which I'll be sharing with you all. Now let's look into the AI agent. So you know that AI is gaining popularity. So everything you see now is being integrated into AI. So if you want to make use of these AI functionalities into your application, we can make use of the AI agent. So these are some common tasks that comes when you're working with the AI agents. So let's say I know all of you might have used ChatGPT, which was like the initial form that came into the public market. So if you type something sentence and leave it, the ChatGPT is completing your query, right? So in such cases, if you want to bring such a thing to your application, you can make use of the LLM text complete task, which will predict or generate the next word in a given text based on the context provided. And then once some data is provided, we need to create the embeddings. I know these things should be like could be non-familiar terms for you, but I'm just giving an fundamental idea on what these are. And I think once we reach the playground, you will get an idea of how to do this. So these embeddings. So whenever we provide some data into an AI model, the model cannot take in that data because they need to create convert it into an embeds. So that is done using this generate embedding task. Embeddings in the sense the vector form. So these models will take in the data and it is converted into vector forms, which is done using this task. And once these vectors are created, it has to be stored into a database, and that is done using the store embedding task. And once it is stored at a later stage, when you want to retrieve the data, it is done using the get embedding task. So this is what happens in tools like ChatGPT. So they are trained using different amount of data, and whenever you are asking something, they are taking this data from the they are providing you with an answer from the train data, which goes through these steps. That is, it is going in searching the embeddings for related data that we're trained with, and then provide create an answer for you and then provide with you. Similarly, if you want to index an entire document, you can do so you can retrieve it later using this task. And if you want to index a particular text, you can make use of this. And if you want to search it later, you can make use of the search index. And one more thing I'll say, which is a chat complete task. So if you want, for example, I've tried an example using this. I've asked the application to behave like a tourist agent, giving let's take one particular destination and give recommendation only about that destination. So if somebody is asking, so we are instructing the model to behave as a particular to take a particular role. So that is what we say chat complete. So whenever somebody is chatting with this bot, it will provide answers only related with the instructions which we have provided, that means which the developer had configured with. And apart from these tasks, we have human task also. So human task, in the sense, the name itself indicates human. So it needs a manual interaction from a human. So when your application reaches a human task, it waits for the manual interaction and then proceeds with the application. So to make it easier, so let's consider loan approval workflow. So this is a workflow. So we have added a switch case, which is checking a condition that the loan amount, the amount which you're applying for loan is less than or equal to 3,000 USD. So if it is less than or equal to 3,000 USD, we have defined in such a way that the default case is executed, which means that it approves it and goes to the next step of the application, which is like requesting the necessary documents and so on. And if the amount is greater than 3,000 USD, it goes to the switch case human task. So so somebody is applying for a loan amount greater than 3,000 USD, we need a manual interaction. So in such case, you can add a human task, due to which a bank employee or somebody can be assigned to check or to manually check the requirement of the person and then approve or reject accordingly. And the workflow will move to the next step based on the approval or rejection. So this is just one example of a human task. And this is a part where you can customize your application to your requirement, which is a worker task. So apart from all these inbuilt tasks, if you need to custom code anything, you can make use of the worker task. So you need to write a worker externally and connect it with the conductor so that you can execute it according to your requirements. So that is a concept about workers which I've mentioned. It requires an external worker and you need to set it up outside Orkes. I think I'll show an example which would be easier for you to understand. So now let's go into the final concept, which is a workflow. So I've begun the session with introducing you to the task. and then followed by workers. So these tasks are the basic building block. And to execute these tasks, we need a worker. And these tasks are all combined together to form the workflow, which is your flow or the application. So the first step is defining application. So there are different ways you can define the application. So you can see these are the different visualization of the application. So you have a different complex case. So it is made easier with conductor. And there are like inbuilt native error handling functionality, like such as, let's say this task fails. So you can configure the task parameters that if it fails, it should retry in 10 seconds, and the number of times it should be retried. Let's say it's a payment thing, so we'll give one retry option or three retry option. That is what we get for the payments, right? So we can configure it to be three, so that whenever this payment as fails, they will be given an option to retry every 10 seconds for three times. And still the payment fails means the application fails there. That is how it works. And there are so when the payment fails, we have to go back through the previous steps to restore. Let's say you were booking a flight ticket. So you choose the seat, which is the first step, and next step is the payment. So payment failed. So we can't stop the application right there. What you have to do is you have to roll back the changes which has happened. That is to remove that seat selection and from the your website, so that it is available for the next person to check out. So that can be done by running a failure workflow. So whenever a step fails, you can run a compensation workflow which compensates a completed previous step so that the application status like normal. And then this is like the visual debugging. So this image itself indicate that there is some error with this task D. So the developer can view the inputs and pull the logs and restart the application, like fix the bug and restart the application without affecting all other services. So it is like it needs only less time to detect and fix the issues, which is like one of the advantages of microservice based applications. Now you need to define the workflow. So the workflows are workflow in the sense the application itself. So you can create it from the UI. So if you like prefer for a low code approach, it is like from UI you can build the application. And if you want, you can create the JSON and build the application. And the third option is using code. So you can custom code it using your like in your preferred language. Now, once a workflow is defined, next step is like running the workflow. So there are different ways by which you can run the workflow. So we have, if you prefer the API method, we have the API stored in the Swagger, which can be utilized to run the work application. And if you want to quickly try it from the UI, you can make use of the UI version. I think for hackathon, you can make use of the UI version, which is like simpler and easier to test it out. And then, as I mentioned, if there are events coming from the webhook, you can make use of the webhook. And then in response to events from the eventing system, this I've mentioned previously, if there is some events coming from Kafka and you want to start the application when the event comes from Kafka, you can make use of this option. And then as a workflow scheduler, this is the example what I've mentioned previously, that is we are running our daily stand-up using a product. So you can schedule the workflow to run at 9 a.m. PSD every day, every weekday, so that it is automated. Now let's look into the playground. So yeah, this is a playground. So when you access it this first time, you will be taken through the execution page. So I think we'll begin with the basics on how to define each things and then go into the executions. So this is how you can define a workflow. So click this button. So start button. So all the tasks which I've mentioned right now, you can see here. So the system tasks which I've mentioned, the operators which I've mentioned, the AI agents, the alerting, the workers, everything is available here. So you can, this is a UI form of building the application. So if you want to call an HTTP endpoint, you can add an HTTP task. And if you click on the task, you can see the task parameters here. You can provide a name, so it like anything you like, a name, a reference name, it would be automatically generated. And then the different methods. So if you like which HTTP method you want to choose, and the other configurations like this you can provide. So if you go check the code tab, you can see that whatever you have chosen, it will be like in the JSON format, which is automatically created by the conductor. So this is the first method which I've mentioned from the UI, and second method using the JSON code, and third is a custom SDK, which is entirely different. So you can see all the parameters here. So let's say if you want to add a switch task. So this is how you add a switch task. So you can provide the case to be evaluated here, and the different, you can add the different cases here. As I mentioned, show the full one, right? So you can provide this case here to evaluate the input amount and different cases, and within that you can add the next set of tasks. um, so this is how you go on building your applications. And I've mentioned about a wait task. So if you check for the wait task, you can say that if you want, so the workflow reaches here and you want to wait until a particular date. So maybe if you want to wait until 31st December 12 a.m. and you can choose your time zone here, so that your workflow, when it reaches here, it will wait until this time. So all the things I've mentioned, all the type of tasks, you can add it here and build your workflow. And whenever you add a task, you have the documentation available here. You can go through it, which is having the details about the input parameters to be configured and what does it mean, and the samples will be given. So you can go through it, and some examples will be given at the end. So you can try these out and build your own application. So whatever be the task type you are adding, you can get all the required details about the input parameters that is available in the documentation, which will help you in building your applications. So this is how you define a workflow. And once you have defined a workflow, you can save the workflow. Now, there are concept called task definition. So I've mentioned if you are custom coding your application, you need to write a worker which is outside the conductor environment. So for that cases, first you need to create a task. So you can provide a task name here, definition here. And this is what I've mentioned, the native retry option. So the number of times to retry the task upon failure, 3 we can provide, and with a delay in seconds. So if it is 10 seconds, you can provide 10 here. What is the retry policy? So the explanation of all these is available in the documentation. So depending upon how the retry should be given, you can choose it. And there are other timeout settings which can be configured, and the input and output keys. So this is a UI building, and if you check the code, you can see the JSON format of the same thing is generated here. So this is how you define a task. Once done, you can save the task definition. Now this comes into use, the event handler comes into use if you're dealing with the events. So it is a kind of advanced workflow. So like you need to create integration first. This would be a bit complicated, but still if you want to give a try, you can go through the documentation and try this. And this is a scheduler which I mentioned. So let's say if this is a stand-up scheduler, we can provide a name. And here you can say it is evaluated using something called the cron expression. So here we have like the ready-made template is added. Suppose you want to run something every hour, you can choose every hour here, and the time zone here, and the workflow, which workflow should run every hour. Suppose it is a demo workflow I want to run every hour, I can like save this. And here also, once you do from the UI, the code will be generated here. So that is how you create a scheduler. And this is the secret part which I've mentioned. So let's say you have some API key. So let's say you have some secret API key, which is having this value. So as I mentioned, if you add this directly into the workflow, everybody who's dealing with that, every developer who's dealing with that can see the secret value. But being a company, these shouldn't be exposed to everyone. So you can save it as a secret key, and whenever you want to use it in your apply workflow, you can use this name so that this value will be called while running the application. So that is the concept behind the secrets. And then we have the webhook. So I've mentioned if you're dealing with webhook, you can create a webhook here. and there are different, these are the ready-made integration available from GitHub to Stripe. And if you are integrating with some other form, you can make use of the custom option and provide the required headers. This example also, the detailed, I think two example, end-to-end example is available in YouTube, which will be shared with you. And if you're dealing with the AI task, this is where you create the prompt I've mentioned, as I mentioned. So you can provide a prompt name here. You can choose a model here. So you need to integrate with the models, and then you can provide a prompt. I think I'll show you. I'm not sure if it is still available. Yeah, there is a translation example which I've created. So this integration is now removed from the playground. That is why it's showing an error. So you can provide a translation, I mean, name for the prompt, which model. So I was testing this with OpenAI text DaVinci model. And this is a AI prompt for translating text into any language. So the template is translate input into any language. So we can test this out from here. So these are certain parameters which when it comes to working with the AI features. So you can provide the input here. For example, my name is something. If you want to translate into a particular language, you can add it here and test it. And then, so the answers may not be accurate always. So you need to like refine the prompt and create the template so that this can be used in a workflow. And then we have the environment variables. This is like you have this value to be recalled at several places within your workflow. So you can store this value as sample URL. And whenever you need to reference this variable, you can use this in your workflow. This is like all making it simplifying your workflow. And then we have the different integrations. So these are the integrations which I mentioned. If you're working with the AI features, you need to integrate with the LLM. So this is, so let's say you want to integrate with OpenAI. So we'll add it here. What we need is only the API key. So get it from there and add it. So the integration would be added. And if you're working with the vector databases, so these are the database integration available here. And these are the message brokers that is available. And we have the relational database as well. So that is the integration part. And we have templates. So we have some ready-made templates which is available for you to try out. This is the example which I've mentioned, the stand-up board. So if you check it, you can it will take you to the blog, which is having the detailed explanation on how you can create this example. So there are several examples. I think maybe towards the end, I will show the demo of how you can apply a filter to an image using a workflow, which is like one of the simple use case. And then we have certain things called application groups user. So if you want, so this playground, if you want to add users to the to your conductor instance, this is something that comes to the admins, but not from a developer perspective. And if you want to group the people into different, let's say, Java developers or something, you can make use of the group. An application is a different concept. I'll show that with an example. And then here we have the API docs. So if I mentioned, if you prefer building with API, you can get the APIs available in Swagger here, which you can make use for testing. And yeah, this is the executions I've mentioned. So whenever you run something, I am the admin to this playground, so I can see all the execution. So you will see only the executions created by yourself or which you have access. So I can see everything here. So this is where you can view the executions, and this is where you can view the schedulers that is running, and this is where the task will be queued. So I think I'll show an example workflow. So I've created a task here. As I've mentioned previously, from definition task, I've created a task, simple demo October. So I've created this because I need to integrate this with a Java hello, like simple application. So in order to integrate that, I've created this task. And I've created a simple workflow. So I've added a simple task, or you can go to the worker task and you can add a new simple task here. That is how I have added here. And once added, you need to map this to the task name which you have created here. So my task name is simple demo October. So I've mapped it with the same task here. And this is like simple. I'm going to demo it like printing the thing similar to hello world. So this is a workflow. Now the workflow is ready, and this is a worker which is going to execute this hello world. This code is like a simple implementation of a worker component. So let's break it down. So first one defines the necessary package of the class and import necessary classes and interfaces. And then we begins with a simple worker class, which is like annotated with a it component, making it a spring managed component. So this is the one that is implementing the worker for your conductor instance, which means that this worker is processing the simple task which is added to the workflow. So we have added the simple task this to the workflow. So this worker is going to process it. So we are overriding it with the task name, which is simple demo October. So that was the task name which we have created and added in the workflow. And then we are going to execute the task. So we are going to set the task result, and a result we are setting into completed. And also we are going to add an output data, which is a message, which is hello from pre-hack session. That is we are doing from the Makeathon. So so let's add the Makeathon name here. So this is like simple of printing us hello world. And then we are going to return the result. So this is like simple worker, which is going to print something to the application or to the workflow. So now this is created outside the conductor, and your workflow is in conductor. So how do you connect this with conductor? That is where this concept called application comes in. So I've created a new application called Demo October application, and I've enabled the worker role because I've created a worker here. And we need to create an access key and secret. So click create access key and it will generate a key ID and key secret. So you need to go create an application.properties file. And here we have three parameters. First one is the server URL. So we are trying it in the playground whose URL is play.orkes.io/API. So that is a server URL. And it is asking client ID and secret. So this is the ID and secret which we created. So I've created this like an hour ago and I've provided that here. So this is now we have this worker which we have written outside conductor and your workflow. So we are connecting those through to by creating an application. So this is how you establish a connection with the external code which you have written and to the workflow which you have created. So now this is not done. This is now creating the connection, but this worker doesn't know to which workflow it should execute, right? That is where this permission section comes. So we will go to permission, click add permission, and it will list all the workflows that is available in the playground. And from there, you have to search for your particular workflow and provide access. So our workflow was a demo October. You have to search for your workflow here and provide execute access. So execute means this particular worker can execute this workflow, and you can also give read permission so that it is visible everywhere. So similarly, you can also add task here. So I've already provided the execute and read permission. So now everything is done. So we have written a worker here. We have created a workflow here and created this application inside conductor, which we have mapped with the key ID and secret and given permission to execute this workflow and this task so that it is done. Now let's run the workflow. So you can quickly run it from the UI by testing from here. So if you run the workflow, you can see that this workflow is in the running state. And if you click the task, you can see that task is scheduled. So now let's go to this application and let's run this. Yeah, so the application is running now. Yeah, you can see that started the application in 6 seconds. So yeah, so now it's completed. So if you check the input as like my email ID, which because I've created this, and if you check the output, the message which we have designed. So here we have defined what to do. We have defined only two things. One is to set the status of to as completed. So you can see that the status is set to completed, and the second thing which we have defined is add an output data, which is hello from pre-hack session makeathon. So hello from pre-accession makeathon is done. So this is like a hello simple word. So depending upon your use case, you need to custom code this in, and then accordingly your application will be executed. And if you maybe to give more idea, so if you go to the summary tab, and you can check the worker which executed this particular task. You can see that my local setup. So I've set this up locally on my system. So you can see that my system detail is available here as a worker which I've executed this. So this is like one simple example. And then maybe I will show one more example, which is the image effects demo. We are going to apply an image to an effect to an image. So this is like already defined. So this is readily available under Template Explorer. So what you have to do is go to this import and like provide append this with some unique name, maybe your name, so that no duplication occurs. So I've replicated the same here. And what you need is you need to provide a file location that is the image which we are going to edit. So I'm going to edit this image. So you have to store it in an HTTPS location and provide the URL here. And then the recipe which we are going to apply to this image. So I'm going to apply a CPR recipe with an intensity of 80. So let's run the workflow. So you can see it is in the running state, and you can see it is completed. And let's check. So this is the same input which I have provided, and you can see the output they have stored into a file location. So let's open and see it. So you can see that the effect is applied to this image in less than 1 second. So this was the input, and we have applied the CPR effect to this image with the intensity I've given 80 or something. And if you go to this simple task, you can see that the Orkes workers has deployed it. This is because this is for the students or the people to try out a product. We have created this as like a ready-made, so that only you need to provide as input URL and the conductor will do the rest. But in the previous case, as I mentioned, you can see that it was my local machine name which was shown here. So it will show which worker has executed this task. So I think, yeah, that was it about the demo. And I think we are already crossed the time limit. So let me know if you have any questions. So,
So,
yeah.
hi. Thank you, Riza, for the amazing session. From work and everything, explain everything very perfect. I think there might be a lot of doubts, but we have a few minutes to discuss about all the topics discussed here. So if anybody has any doubts, please just drop them in the chat or raise your hand and we can move into it.
So I know this concept should be like new for you all. So while trying out in playground, you may have doubts. So that is why I told that we'll be sending, like on the hackathon day, we'll be sending two persons from a company as a representative. One of them is like a software engineer. One of them is a DevOps engineer. So they'll help with your queries. But before that, if I recommend you to go through these templates, which is readily available. Yeah. Is there any upper limit on the number of workers or when you can spin up? No, there isn't like a limit on it. You can set as many as required. I'm not sure if I can show you something. There are some production workflows that is running currently based on the like adding a large number of workers. So you can set it up. There is no issues in that. And there are like even customers of us who is running billions of workflows a month. So that scaling is not an issue. So as I've mentioned, there are like templates that is available. So I would recommend you to try with templates. I think one of the template is having some internal issue. The rest should be working fine. So you can try out with this template. And while coming up for submissions to the conductor track, don't just submit the template itself. What you can do is you can take the template as a reference and bring some like tweaking the code here and they are bringing some innovations to that template. You can do it as like make it as a reference, but it will speed up your process. So I think Anjana, I can share the links which I've mentioned like during the session. I've mentioned about too many examples. So there are like working links that is available, which I'll share with the organizers email, which you can use to like you, which you can share with the participants.
Okay, thank you, Riza. Again, thank you so much for the informative session. I'm pretty sure we all learned a lot about conductor microservices and how we can integrate that into the applications. And I think with this, we come to the end of the session. So thank you so much, everyone, for joining in. And I hope to see you at the hackathon.
Thank you.